In this video, we're going to have a look at function notation. We already know that each function can be represented by an equation. When we're working with more than one function at a time, it can get a bit confusing as they all start with y is equal to, and that is why we use function notation. In function notation, each graph gets a name, and usually that name is an alphabet letter. For example, we can say that our first graph is named G, our second graph H, and our third graph K. And in function notation, the y value in each equation is then replaced by the function's name and x. This gx then means function g in terms of x is equal to. Similarly, for our second function, we can substitute the y with h of x, and in the third function, k of x. All three of these still represent the y value of that specific function. Let's go and have a look at what type of questions can be asked of you using function notation. Consider the function f(x) is equal to 2x squared plus 1 and determine the following. Remember that any function consists of a whole lot of coordinates, and in our function notation, x is still represented by x, but y is now represented by f of x. In the first question, we are asked to determine f of 4. So can you see that instead of x, we are now given 4, which means that in this case, the x value of a coordinate is given as 4, and we are asked to determine the y value. To determine this specific y value, we are going to take the right-hand side and repeat what was done on the left-hand side, which is substituting x with 4. So once substituted, this will give us a value of 33. Remember that f(x) represents the specific y value. So in this case, the y value, when the x is 4, will be 33. In example 2, the x value is not given, but this time the whole y value is given as 19. So again, we are asked to determine part of a coordinate, but this time the y value is given and we need to determine the x value. That is why this time I'm going to take my equation and on the left hand side substitute the whole f(x) with 19 so that I can solve the x on the right hand side. Then you will see that there are two possible solutions for x, and x can be 3 or minus 3. If you go and do an accurate sketch of this graph and read from the y value of 19, you will see that you have two x values, one at minus 3 and a second one at 3. And this is exactly what we just determined. In question 3, we are not asked to determine a x or a y value, but here it's all about the transformation that the function undergoes when a 2 is multiplied to the front. This 2 will then also have to be multiplied with the whole function on the right-hand side of the equation. And once you've done that, you will have 4x squared plus 2. The 4 shows you that the a value increased and the arms of the parabola moved closer to each other. The 2 indicates that the graph moved up one more unit. So instead of describing this transformation to you in words, it can also be indicated using function notation. Similarly, in example 4, transformations are indicated using function notation. The minus in front indicates that the function is reflected around the x-axis because the whole function's sign is changing. After that, the function also moves up 3 units. So when determining the equation of the newly formed function, the whole equation has to be multiplied by a minus, and then after that, 3 should also be added to the equation. So the new equation will be minus 2x squared minus 1 plus 3, and finally then minus 2x squared plus 2. From these examples, you could now see that function notation can be used to give you the x value of an equation, and then you can determine the y value, or the y value of the coordinate can be given so that you can use that to determine the specific x coordinate. Then we also saw that function notation can be used to indicate all the different transformations.